we left off last time talking about polygons and angles within those polygons. And so that's really where we're at. The idea that if you have a piece of information that's given about a polygon, can you figure out additional information, particularly angles? All right, so I'm looking at a general rule here that we developed together as kind of like my blueprint for that. So they're saying if the sum of the interior angles in a polygon is 2,340, find the number of sides in a polygon. All right, I'm gonna get my calculator out. Why I didn't do that first, I don't know. Forgive me if I've said this one before, but I used to get on students' cases for not having their calculators out. Like, how could you be in a math class without having a calculator out? And then I realized I never have my calculator out, so kind of makes sense. We're all on the same page, literally and figuratively. All right, so, oh, I don't need that. And again, you don't need a fancy calculator, but if you have a graphing one, it tends to be helpful. There is just, while I'm going the stream of consciousness route, there is a GeoGebra app that you could download, and that has a calculator feature to it. And I'm perfectly fine with you using that for assessments, because there is a component of it that'll actually lock you out of using the more advanced features. So basically, you can't use the other aspects of your phone while you're using this app. The one drawback to that I've noticed in the past is people forget to unlock it before they leave the classroom, and then they don't have the ability to use their phone the way they want, and that's kind of devastating. So, so it's a pretty big reason why one would not want to use that feature. But I could talk more about that in a little while. Some of the interior angles of polygon is given as 2340. This rule that we developed last time, assuming my pen wants to work, gives us the sum of the interior angles of any polygon. So all I'd have to do is set that equal to 2340. And then spend the next half an hour trying to write it with this interface. All right. Now, you can kind of play around with this, guess and check, and use strategies along those lines to figure it out. Another way to handle it would be, if you do have a graphing calculator, to use the graphing feature of that calculator. But again, I can't make the assumption that we all have that. So what I'll do is I'll just show you the algebraic approach. I'll also show you, because if you do have a graphing calculator, this could be something worth looking into. I'll just show you the algebraic way of doing it for now. So distribute through the n, you'll have a 180 n minus 360, and that's going to be equal to 2340. The n's cancel out, yeah. So then I'm going to add 360 to both sides. So it's a linear equation. So nothing too fancy. Yeah, we just have to add 2340 and 360. That's going to be what, 2700? Is equal to 180n. And so we would divide both sides by 180. I don't have the room for it, so I'm just going to jump right to the answer. But I'll do it on the calculator. So 2700 divided by 180, and you get 15. All right, so this is a 15agon, or 15gon really. It's just 15gon sounds weird. 15agon doesn't sound much better, but it in my mind, I just can't not put the agon in there. Yeah, so a 15-sided polygon. If you get something other than a whole number, then you did something wrong. It's as simple as that. Because you can't have a fractional number of sides in a polygon. It just wouldn't be a polygon. And it wouldn't be a closed figure. Number 15 is going the other way. One of the interior angles, well, that's not true. It's not directly going the other way, but it's along those lines. One of the interior angles in a regular polygon is 156. Find the number of sides in the polygon. All right. So this one, honestly, I think you're I mean, the formula is great, but I feel like this is probably a better situation, or the better approach to this situation would be to kind of go back to scratch. If you know that the polygon has an interior angle, well, it would be obtuse. Not that it really matters. An interior angle of 156 degrees. So that's our interior. Then 180 minus 156 would give us the measure of the exterior angle, which is 24 degrees. All right, the sum of the exterior angles and for any polygon is going to be 360 degrees. So again, we'll take the next 20 minutes trying to write this out. Sum of exterior angles is equal to 360 degrees. So if I take my 360 and divide it by 24 degrees per exterior angle, then I get 15. All right. So that tells me that I'm going to have 15 exterior angles. They're asking for the number of sides, but the number of sides and number of angles correspond to one another. So if I had 20 sides in the polygon, I'd also have 20 angles. Right? Interior or exterior, it doesn't matter. But long story short, we got another case where this is an n equals 15. The number of sides in that polygon is 15. All right. Now, it turns out that that's the same as the answer to 14, but we couldn't have known that going in. That's not a likely assumption. Well, I'm going to take a shot in the dark. I think both of them are going to be 15. Well, question number 15, you might be onto something. The answer is 15. There's nothing to it. I mean, it's just you got to do the work. All right, sum of the interior angles of a polygon. So same idea as number 14. So we could use this other approach. So 1080 would be equal to, now if you're if you're anything like me, you're always looking for the shortcut, while also understanding the concept. This here simplified to be the same as this in general terms. There's no reason to think that it would ever be anything different. So I could just jump right to that and call it 180. So basically have a simpler version of my formula. So you kind of cut to the chase a little bit quicker. All right, so I'm going to add 360 to both sides. So 1080 plus 360, 1440. So that 1440 is going to be equal to 180, poor quality 180. Fix that. Bless you. So divide out the 180 and you'll have 8. So we're looking at an octagon. All right, it didn't ask us to name it. Honestly, I tend to not ask you to name the polygon, even though it's kind of, like you should know that an 8-sided polygon is an octagon. It's just I've taken off too many points over the years for people calling it one thing when it should be another, even though they did all the math right. Yeah, what's up? That sounds great. It doesn't matter.
Okay.
Yeah.
I just want to check because some teachers are like, no, I want it specifically this way.
There's only a handful of topics that I teach that's like you got to do it this way. This is not one of them. Yeah. Anyway, so number 17, similar to number 15, we have the interior angles in a regular polygon as 108. Right. So like we could draw a diagram again, but essentially what we did was we took the 108 and subtracted it from 180. That would give us a 72. And then we took that number and divided it into 360. And so we get 5. So it's given us 5 angles. But number of angles correspond with the number of sides, so therefore we would say n is equal to 5. So this would be a pentagon, but again, not a big deal. You don't have to worry about naming it. I'm just trying to think. And I don't, honestly, even for questions when I ask, like I'll ask you questions on a test, I don't even refer to them by name. I'll say given a 5-sided polygon. I won't say given a pentagon. Because it's just one of those things like, you know the math. I don't want people losing points because of, just naming rights basically. So it's simple, but it's kind of the way I operate. Okay, let's see. Alternate Shift Q, if I remember. Oh, that was a sound. Window Shift Q.